So, hello everyone. Welcome to this first meeting of webinar series Augmented Human Intelligence for your value chain. I propose to you to start. I'm Lucille Picon. I'm Chief Marketing and Innovation Director at Gigli and System Value. And I'm with Vincent Ollet, founder of those two companies. Welcome, Vincent.
Hi, everyone.
A few words about these two companies. Vincent, we will show you more after. Gigli is a company offering an augmented human intelligence software suite, and System Value is a consulting firm supporting its clients on strategic transformation projects. So the webinar cycle is broken down into 6 sessions. One, today, introductory session to address the major issues and concept of augmented human intelligence. At the end, one concluding session to share the synthesis of strengths and areas of improvement of augmented human intelligence to meet your objective. So it will be on June 10th. And between the two strong time, we have 4 thematic sessions to get into the issue and opportunities for 4 essential components of the value chains of companies: engineering, finance, human resources, and marketing innovation. So on May 6th, we will focus on the question how to make the right decisions on design, a recurring issue in engineering. After, on May 20, we will discuss the links between finance and the roadmap in order to maximize the benefits for your company. So we have engineering, we have finance. It's good, but we need talents, collaborators, and human resources to collaborate and work on projects. So on May 27th, we will address the topic of how to build the right team to achieve your goals. And to finish, last but not the least, on June 3rd, we will share with you a key issue for marketing and innovation experts, how to define the right scope of ambition to be different and to innovate. So today, the program. Today's session is dedicated to the opportunities offered by augmented human intelligence, especially for mastering the extension of the engineering value chain. So first time, Vincent will explain what is meant by HEA to present. So after he will present first demonstration of project and the 3 key steps for deployment and operations, the augmented human intelligence, Then we propose to introduce in a concrete way the topic of the 4 thematic sessions, so with engineering, finance, human resources, and marketing. And after, he will give example of generic application that we have created from cross-cutting topics. After a quick summary, we will open the program to question and answer. So you can put your question in the right corner, the right banner of your screen. And don't hesitate to ask your question during the presentation. Sorry, I switched between my screen. So before giving the floor to Vincent, I will quickly introduce his background. He is engineering doctor. He has evolved for nearly 10 years in the heat of high-performance system. Yeah, his chief traces with Schlumberger, and then as expert position in various consulting firms. He noticed the underexploited potential of multi-actor projects, and therefore, progressively, he developed quickly on his personal time. 5 years ago, he took the plunge and founded Giggly and System Value to implement his vision of industrial design and his conviction that the integration of AHT is essential to design and master current and future industrial problems. So I wish you an excellent webinar to all of you, and Vincent, I leave the floor to you.
Thank you, Lucille. So I will share my screen. Here we go. So hi, everyone. Thank you very much, Lucille, for these introductions. So I see on the participants some French guys. So this webinar will be in English, but we had the same one in French at 1 p.m. today in Paris. So you will have the replay also, but please stay with us. I think it will be great to have you and to discuss at the end of this webinar. So today I'm very pleased to be here with you to present you not the new Giggly, instead of we have a new Giggly, but to show you the extended augmented engineering value chain that we are now managing in order to complete the value for the companies. Okay, so today it's a very difficult webinar for us because we are going to talk about engineering, but we are also going to talk about innovations and perimeter of ambition. And then we'll talk about human resources in order to link the choose of the best team in order to reach the objective of our engineering design, for example. And at the end, we are going to talk about financial objective of financial engineering in order to link the development roadmap, technical point of view, with the benefits, what we call the net present value that a company can gather from. Okay, so we are here around this webinar because we are probably many of us around the same issues faced to all the whole industry have. So basically, since 4 years, as Lucille introduced, we are well deployed in the whole industry around the world. So if I start by the bottom part, we are working for aerospace industry in the main fields of imagine the future of launchers, of satellites, imagine what could be the right platforms able to cover a wide variety of needs over the next decade. We are also working on the right part of the slide about energy industries with some names that you should know. So the basics issue we are tackling on this field are on the design of next generations systems, taking the right decisions, designing command and control systems. So everything where we want to make sure about the decision we take. We're also working on the platform for gas and liquefied gas, on the main balance between on grid, between renewable and non-renewable energy. We are also starting to work with healthcare industry. It's growing, even if we are not really involved in this field up to now. We are working a lot in defense, so basically because it's strategic, and we want to make sure that everything is working correctly. So especially we are working in data center systems. We are working also in railway industry, especially in the field of collaboration between company. So we are working in extended companies, as we are saying that. And we are working also in the automotive industry to make rational, the irrational way of knowing from the people in this industry. And we are working on the selection of the right technologies in order to be able to cover a large set of possibilities and usage of our technologies. Okay, so today I will try to be very covering a large scope of our activities. I'm going to show you some example, non-confidential example and demonstration that we created from this experience. Okay, so all this industry are working with us because they are facing the same issues. So basically, as you know, and I think that all of you will be in line with me, we are remarking that engineering a product or services has never been so difficult up to now for several reasons. The first one is that we are not expecting anymore just to optimize the cost or the weight of the systems, but we have to manage a lot of trade-off on several performances. So the equation is much more difficult to manage. Even if we are on the 21st century, we are remarking that we are many iterations and errors to converge to the final concept. This is due to the fact that disciplines are really involved and involved together in the design of the same systems. So they are really more linked now that it was 10 years ago. And this will create difficulties in the trade-off management and the optimization of the systems. So the remark, the issue is that we are iterating much more, not in order to optimize the product, but just in order to make sure that the product will be feasible, basically. So it's not valuable for all of us. One question that we are a lot of time called to answer is that what is the right platforms or the right product line to cover a variety of needs for a variety of a market or for a long time perspective on the systems. To answer to these goals, we are also called a lot of time to answer the question about to reach the next step of performance. Do I need to do incremental innovations or breakthrough innovations? So a lot of times we can remark that we do not need a breakthrough innovations in order to reach a next level of performance. We are going to show that during this webinar. And moreover, up to now, we are not anymore designing a system, what is a product or services, without considering the overall value chains, so all the life cycle value chain that we have. So basically the maintenance, the obsolescence, and the cleaning of the system, and so on. So all these findings are around one key point, that is we have to collaborate much more today than it was before on the systems. So this is a technical perspective of a problem settings, but basically up to now we are dealing with much more background questions. So basically the questions that are coming from the whole industry is that, is it the right scope of emissions? So those the problems I'm going to design is take into account the right perimeter of the systems to make my product competitive regarding other industry. Those I'm on the right roadmaps, okay, because I'm scheduling a roadmap development of technologies just to maximize the benefits for my companies and its competitiveness. And the third question that we are dealing is that I cannot find the right concept on the right parameters, but if I do not have the right teams to design it, to reach the objectives, I could fail. So basically, we are seeing on the industry that we are touching much more dimensions that we have usually in mind on the design of the project, because here we touch engineering perspective, so technical performances and so on, as you know, but we are also reaching a part of innovation. So what is the right set of the needs? we are touching human resources dimensions, okay, which is the right teams to design the right product. And we are touching the financial perspective of the company, especially in these periods where it's very difficult for all the companies. So to make sure that we have the right roadmap. So we are going today to introduce you some key elements, some key KPIs on all these subjects. So the goal of today is not to have the same webinar as we scheduled for the fourth next webinar, that we are going to deal in details in all these subjects. So up to now, I'm going to present you the hat of the webinars. And I'm first going to introduce you, as Lucille said, what is augmented human intelligence tools, as Gigi. So to present you what is augmented human intelligence, I am pleased to introduce you someone that you should know, I think, or you will. It's Daniel Kahneman, so an American researcher in the way of thinking. So what Daniel says is that we have two ways of thinking, okay? The first one is called system one, and the second one is called the system two. So the system one, we have all two, the two. When we are working on something, working on an issue, we are still working with the two. So the first one is also called the think fast. It's the systems where we have located the intuition and the instinct of your systems. So basically, when you are faced to new problems, we all have basic idea, intuitive instinct that we orientate us towards some solutions. Okay. This system one is much more bigger when we are old, when we have an experience, because when we get orientations, we are working with the system two, which is called the think slow system, which is to study in details the system. So basically, when we are faced with new problems, we take some orientations with the system ones. It's a very intuitive and instinctive way. And then when we get the orientations, we are studying in much more detail the problem settings that we want to solve based on the rational thinking. Okay, so this is a basic way of working. We are dealing with it every day on every problems we have in real life, in current life, and in professional life, which is not a problem. The second thing that Daniel introduced is that the system one is the big one. So basically, it's an unconscious one, a fast one, but is also gathering decision toward an objective, orientations, and with the system one, we avoid 95% of the perspective. And basically, the system two is focusing only on 5% of the details. So basically, if we are very experienced people that work a lot in system two during his career, we have a large system one that is very powerful. So we can consider that we have a good system ones. Okay, when we are young, it's less evidence. But now imagine that we are working on a collaborative project. Okay, when we are working on a collaborative project, we are several disciplines working together. If each of the disciplines will focus and take orientation with their own system ones, we are going basically to reduce the design scope for the overall project. And sometimes the orientation that we took in one disciplines can be a difficult challenge for another disciplines. So another way to represent that is, for example, if we are dealing with a project with 3 disciplines, as I show you here in green, blue, and red, if we are working each of us with the system 1 and then system 2, we are dealing to study just the perimeter of the green area on the middle of each disciplines. And if we do not consider our system ones, we will be not able to extend the potential of your perspective. And sometimes we will avoid, we can imagine to avoid the best solutions we can find. So the perspective of the augmented human intelligence and the software added to them is to open the mind of the engineers and to challenge them by exploring automatically. You will see how we can do that. The overall design space and the space of all the feasible solutions for each discipline. Okay. So why it's very important to take that in account? We all know that the first decision are keys. So basically, in engineering perspective, we all know that the first decision we took are a large impact on the cost, because the first decisions involve commitment costs that we do not spend, but that we will spend at the end. So basically, if I take the example of the plane that I show you at the beginning, the mono wing plane, when we take such decisions, and especially if it's a carbon plane, for example, the cost of the plane will be very important at the end, for sure. Okay, so this is well known for all of us. What is less known is that we have also at the beginning of the first decision, we took orientations that will fix the trade-off we will have. If we take the decision to have a carbon fiber plane, for example, we know that at the end the plane will be very light, but will be also very expensive, and it will be impossible to change the trade-off towards the same trade-off as an aluminium regular plane with two wings for engine and just one fuselage. Okay, so it's very important to catch it at the beginning of the project. So so it's basically the goal of Gigli tools to work at the beginning of the project to make sure that the first decision we took on the project was good and are good. We are also working downstream of the design cycles in detail designs when we need to have a step back on the project and to say, okay, we have a failure, we have an issue, what we must change on the project to make it feasible again. Okay, so another way to represent these problems. So I like this slide because they are coming from one of our clients, Airbus, where they show that at the beginning of a project, usually we consider only few disciplines on the project. They are working as they know exactly, and sometimes they make a small part of innovative design area. And when we move forward downstreams, we are focusing much and more on what we know to do. And finally, we are not challenging our comfort zones, and we are not going to find innovative or very successful potential solution, architecture or solutions around the comfort zone that we usually take. And it's basically where huge company with a large growth will come to challenge the current large companies on the world, basically. Okay, so as Lucille said at the beginning, we have 3 steps that is very important in order to deploy augmented human intelligence. The first one is to bring together expertise. Okay, so we have expertise, expert on a company. We want to put all around the tables. This is the first step. So it can be done with a consulting firm as System Value, for example. And the second step is to model their know-how. So we will have today an example about how we can model expertise. The second step is to model it. And then the third step is to exploit by using some engineering intelligence tools in order to place scenario and to take the right decisions. So it's basically the step 2 and the step 3 that we are going to highlight quickly today about engineering, but also about human resources, financial engineering, and innovations. So to do that, we are going to introduce you today the 2 software on the value chain of Gigli. So the left one, you have the Gigli pattern, where we capitalize the know-how from the disciplines. And on the right part, we have the Gigli intelligence tools on which we play scenario and we exploit we use the know-how that we capitalized. Okay, so just to make sure that it's very clear, I propose you to move to the software and to play with real data and real project. So I will start with the Giggly Intelligence software. So to introduce this software, I propose you to work on a very simple project where we are going to design an electrical parking brake. So basically, we want to electrify an existing function on a car, which is the parking brake, which is usually this large shaft on the middle of the car that is powered by a cable and moving actuators on the brake. So what we want at the end is to replace it with a small switch inside the cockpit of the car and to consider the same disc brake. And we want to create just an electrical functions to convert a signal into a mechanical displacement, basically. Okay. So even if the scope of the project is very simple, it's very complex to reach the market because we have several stakeholders to fulfill. So we have end users, you and me, basically, that can be a different point of view and profile based on our own culture. And we have another very important stakeholders to satisfy, and this is the car buyer, the car maker profiles. And following the type of the car we are going to buy the electrical parking brake, we are not expecting the same thing. Okay. So as on all the project, the design team start to analyze the needs, to break down system into subsystem, and finally they reach such analysis based on the fact that we have three main functions led by three engineers, and another one that is a protection subsystems. So each engineers have in mind all the possibilities that they can imagine from their own point of view, okay, to solve the problems. So in the current, in the classical engineering approach, we will start to have meetings to discuss between disciplines in order to select what could be the best or the right product. So basically, we can imagine that discussion between disciplines with their own know-how, with their own knowledge, with their own KPIs and language, basically, and that at the end of a very what could be a long meetings, we can have such agreement on what could be the best architecture of the systems. Okay, so when we said that, the question we have is that this mix of technology will reach the market. So markets, we have end users and car makers. So basically, the first information that we get from this human intelligence software is that the solution we select is non-compliant with Jack and even Paul profile. So basically, we are not fulfilling any requirements of the systems. And we can also remark that we are not fulfilling the car maker profile because we are not compliant with the French car maker and we are not compliant with the Porsche car maker. Okay, for the same reasons, we are missing one requirement on the expectations following the car. So what's next on a current and classical design engineering approach? We will try to change some elements of the architecture or the configurations until we reach some feasible points, which is not very efficient, and we are going to iterate a lot. So I propose you one thing. So forget this way to approach and get right way to approach with an augmented human intelligence software, which is to, okay, we are not focusing on the techniques aspects, just focus on what we expect at the end. So for example, I can decide to ask to the software, please find me solutions that are compliant with Jack profile. So I click on compliant on Jack profile. It's thinking and he's telling me we have 16 architecture or configuration that is fulfilling Jack profile. Okay, it takes 1 second. So it's very interesting. So what's up behind this software? It play any breakdown that we learn from engineers, and he finds the right combinations of technology that is feasible in order to achieve Jack expectations on all the requirements that is interesting by Jack. Okay, so now I can ask to the software, please find me the platforms able to fulfill Jack and Paul profile. So I click on compliant on Paul. He do the same thing, and he's telling me that we have 15 solutions on the top left here that is feasible to answer the platform needs. Now, if Jacques and Paul buy a French car, we must satisfy the French buyer. Okay, it's remaining 9 solutions. And if Jacques and Paul buy a French car that is compliant with a Porsche Panamera profile, for example, it's remaining only 1 solution. So it's the hazard. So we can have 0 solutions. And now, if I move to the architecture configuration, we can find which one is the right one. Okay, so in this phase, we remark that with augmented human intelligence, we are able to shift the paradigm by moving from technical considerations up to system level perspective, fulfilling directly the goal of the project. Okay, so the right way to use such software is to create data page, okay, which is technical page for discipline and so or technical point of view, and it's to create basically a scenario of analysis that we can find here, basically by analysis the cost, the investment, or the time to market efforts in order to be able to analyze the systems. Okay, so now your question might be to say, okay, so how we can create such powerful systems. So let me to introduce you the giggly enjoying pattern. So for the clients we had and that are present today, this is a new giggly engineering pattern that is coming in few days in your mailboxes. So it's much more close and related to system engineering. So we have now 2 main phases, the black box view of the systems and the white box view on the systems. So on the black box view on the systems, we still have to describe the problem settings we want to tackle. So basically, if we are dealing with Martian drones, I will describe that we are expecting an autonomy at max payload. We are expecting a certain amount of flight per day, and we are expecting a charging time between 2 flights, okay, with dedicated value that is conform to a mission profile we expect. And we are now on these new versions able to set directly some environment, as we are going to fly on Mars. We can imagine to fly on Venus. And we can select and list some river on which we are going to interact. So some of them are already on March, and others will come on the next window. Okay. So we list here the environment of the system and the objective. And on the next elements here, on the beginning of the white box, we are going to list any subsystems that can participate to the overall design of the Martian drones. So basically, we can have battery cells, communication cards, flying instruments, and so on, with the list of alternatives. So basically, to reach the design of a battery cells in order to design the battery pack, to add power to the engine, and to create the motion on the rotor. We can have some new cells of battery that we are going to design, or we can use some cuts component of the shell that's already defined. Okay, and each of these alternatives will be then listed with their technical characteristics. As for example, on the battery, we have a mass, we have a volume, we have a cell capacity, a cell discharge, a cell type, and so on. Okay, and we can see, so it's a novelty from these versions. For our clients, we have here a selector of the quality of the information we select, we set on the database. So basically, for the well-known cells that is COTS systems, everything is well known, and for the systems that we are going to design, some information are inputs and others are calculated, so we are not very sure about the fact that we can reach this objective. So basically, we are able to manage the uncertainty on these systems. Okay, so on these 2 steps, we create the objective of those systems with the black box view, and we start to list any elements that's on which Giggly or any human intelligence software can play with. What is missing is the way of thinking of engineers. So it's the huge part on which we work at Giggly since 5 years. we had the objective to be very easy for engineers to be used and very close to their own cultures. So we decided to create almost an Excel that can be used in natural language. So basically, for example, on the Martian drone, the engineers in charge of the mass say the drone anti-mass is calculated based on the mass of the structure, plus the mass of the electronic, plus the mass of the power system, plus the mass of the rotor system, and so on. Okay, and we can write it down as that exactly as an Excel, but with space and natural language. Okay, and we have to list here basically all the rules we have in mind. So coming from system 1 and system 2, if we need, we can be supported by a consulting firm in order to be able to detect and to put right on the table the system 1 way of thinking. We can have some physical equation, as the induced power here coming from the motor to the rotor. So it's much more easy to read it as a LaTeX form here than in Excel forms, even if in a larger natural language. So we still have some references here to calculate the correct value of the equations or the rule we set. A novelty is that we have on this version that we are able to select the maturity of the rules we add to the systems. And with that, Gigli is able, when you finish to check the model, so it's a novelties from these versions, we are not now able, so I have some mistake on the model to show you. We are not able to analyze the quality of your model based on some rules that we learn from the previous models. And when we say that, we are able to generate the way of thinking of engineers. So on the first webinar, we are going to show you exactly how it's working and how to read the correct network of analysis, which is interesting to understand the way of thinking. But the real value of the system is to be able to program itself in Python and to embed all the technical solutions that we list here and to create dedicated applications, as I'm going to show you, for example, on Martian drones. Okay, so basically it's generating a file on which we can analyze the problem settings. So for example, here, if we want to create an observations mission drones or a cargo drones in order to solve the problem settings, and we are able on this tool, as we did previously with the electrical parking brake, to be able to select a cargo drone flying for 10 minutes, for example, so moving to get a rock, and we are able to move to the architecture data page and to see that some motor reference, for example, is feasible to reach this objective, and other might be not feasible, or are not feasible in this case, basically. Okay, it's not linked to the technical parameter of the subsystems. It's linked to the fact that Gigli play the way of thinking you learn to hit, and he find no solutions feasible for this type of motors with an association of this type of cells and so on. Okay, and we are now able to play any things we want, to have all the breakdown we learn to the systems, and we are able to play in any way we want some constraints and to see the impact on the technical decision we have to take in order to solve the need. Okay, this is the principles behind augmented human intelligence tools. So here we was talking about engineering, okay, which is very interesting already, but we are missing some dimensions. So basically, if you want to have a great product at the end, we want. Sorry, I close it. We want to be able to find the right team in order to design, for example, the Martian drones. So if you have a look on the dimension human resources application that we created with MPF Paris, which is a company dedicated to the management of the people with their intelligence way of working. Basically, they are. I'm sorry, this presentation is in French, so I have to translate it in English. It's based on soft skills and hard skills analysis. So the goal we want to expect at this stage is to be able, for example, for problem settings, a project where we will involve several disciplines working together, is to set the right choice of the team members in order to reach the objective. Okay, so traditional approach is usually to, I can play it for you, to select design team members based on their hard skills, so basically competencies. So I'm for example, playing one example here. Okay, so the project is, the software is syncing. And what is going to say, okay, I have what it looks like from an hard skills perspective, the best teams. So now during the life of the project, I'm going to detect that we have frictions or fatigues between design team members, based to the fact that some soft skills are not in phase on some discussion and so on. And if we are working in teletravail, meaning that at homes, we can also have some very important risk on the personal state of the peoples, which can be not acceptable at all for the company, for the project, and for the peoples. Okay, so as you learned before, the augmented human intelligence approach is not to think about the design teams or the modules we can play with in order to create the systems. It's much more relevant to say directly which are the risks I want to take in order to, for example, to choose my engineering team. So, for example, if I select to minimize the risk in home working up to now, I can quickly have the information that I can have 4 days maximum per week of home working. And if I select the 4 days of homework per week, I can see that we have a converging design teams that will be able to challenge the scenario I'm playing here, basically. And if I want to select the right manager that will decrease the risk of friction between design members, I have my convergence toward my right design teams in order to answer my needs. Just over there. Okay, so this is one scenario. So we can play another scenario that will be not oriented on the team, that can be oriented on the systems we want to design. So basically, on these systems, we are saying that we have 4 disciplines working together in order to design 2 main functions. Okay, so we have place on interfaces where collaboration will be very important. So what we can do with such tool is directly to say, okay, I want to maximize the benefits of the interfaces. So basically to reduce the risk on these interfaces. So I can, for example, select to minimize the risk on all the interfaces between disciplines that I'm going to have involved in the project. This will lead to have a convergence of the design teams, as I had previously on other scenario. And if I say I want to minimize the risk of the design team for the teams, I will have another selection of the teams. Okay, so this is what we are going to explain you in much more details on the third webinar series, the third webinar of this series concerning human resources. Okay, so this was talking about human resources. We was talking before that about engineering analysis. We can now, for example, talk about, I'm sorry, it's just a wrong click on my side. We can talk about the analysis of the financial perspective. So it's another application that we created with Open Lab management. So the problem setting here we want to tackle is to, for example, to design an internet box we have in our house, which is basically made with several electronic cards, several software and so on. So a lot of components on which we can have a large diversity. So the goal of this study is to set the right roadmap development. So basically, which box and which component of each box we want to to design first. So in a traditional approach, we will have, for example, very iterative way of thinking by saying, okay, we think that the box A must be done in the first year. Then we can imagine to create the box B, and at the end to design the box C. So if I release the software and ask him to calculate the implications of these decisions, we can remark that we can have between 17 and 55 FTE to design such systems. So based on the analysis of timetable and so on. So we can have also some large non-working area. So if I said, for example, that I have only 28 FTP to work on this project, I'm going to set which number of people we need on hardware and which number of people we need on software. It's calculated based on a model of sales. So this model will be explained during the second webinar of this series. So how much sales and market shares we can have based on the quality and performances of systems we can have we can commercialize on the markets. And for example, here, the software will calculate the NPV, so the benefits of the company, the net present value that we can have on this period. So basically here we can reach almost 300 millions of euros of benefits. But we can also see that Gigli calculate that we have the opportunity to reach almost 600 millions of benefits. So now the question is how we can do that. So for example, I can reset the systems and maybe have an approach of a scenario based on the number of FTP. So on the previous scenario, we seen that we had 28 FTP feasible. So I can select the number of ATP up to 28, for example. So it's calculated the arrangement of the systems, and we can directly select the best NPV we can have. Okay. So we can see here that even if we are missing the best NPV, we are very close to the maximum NPV. And now, if I select the best NPV, which is 540 million euros on the period, so it's twice time more than before with the same FTP, so the same people, and the software is returning that we have to start in 2021 by the design of the box C, then we start the design of the box B, and at the end to design the box A, which is there. So it's basically the opposite of what we seen at the beginning, maybe based on our own system once, and we will maximize the sale value and the market share on each year. Okay, so this is an example of what we can do and what we need to do, in fact, by linking engineering and financial perspective of the company. Okay, now we can switch on another one. So up to now we deals about engineering, human resources, financial engineering, and the one which is missing is the innovation perspective. So we work on an application with Hybrid, which is a strong company in the management of innovations, augmented innovations, which is dedicated to the fact that we need to analyze in a better way what is the right perimeter scope of analysis at the beginning of a project. So here I'm going to show you an example of mobility in Ile-de-France, close to Paris, so around Paris, exactly. So basically, this application will consider end users, mean of transport, and travel patterns that we call also activities. So the systems embedded, the know-how embedded by Hybrid into Gigli leads to be able to analyze the technical solution existing on the markets, the end user, and the remaining pains. So the remaining pains that we want to tackle, and based on their own activities. So the first information we reach is that we are some expectations based, instead of talking about stakeholders, we are talking about activities for the different stakeholders, which is much more rich in terms of analysis of the real needs. Okay, and when we do that, they are analyzing what are the right level of constraints or expectations on different characteristics, we can almost say requirements that we are expecting. So basically here, in a very visual way, we are able to analyze that it's not needed to reach, for example, the comfort of a private car in order to satisfy most of the end users, but we must be a bit better than subway on use times, on air quality, and so on. So it's a clear view about what we expect, and using Giggly, we are able to test different configurations as the right one, which is one solutions that we can imagine to create a new mobility way of thinking. And we can quickly analyze that we are not reaching at all the basement expectation for some activities of end users. And so basically we can imagine to switch from different story and end users and technical solution in order to fulfill any requirements of this end user based on activities analysis. Okay, so I see the times running a bit out, so I'm seeing that I'm a bit longer in English than in French, which is strange, but whatever. Okay, so maybe let's move back to the presentation and to conclude it. So I didn't have time to show you, but we have developed also some application that we are going to show you on the first webinar about engineering, which consider system of system analysis. So basically it will be based on the AUV underwater rover. So I present you on some demo, some dedicated application. So basically what clients of Giggly can do with such human intelligence, augmented human intelligence software. We are also deploying some applications as, for example, how to architect and optimize a wind farm. So we basically create the capability to set a field size, so meteorological aspect on this wind farm, and we import inside Giggly the 1,181 windmills available on the market, and we have now a generic model able for a field and from the wind conditions to set the right turbines with the right arrangement into the field to maximize the capacity of the wind farms and to decrease the capex of the systems. So this such application will be soon available on Giggly. We also developed some application case to analyze the overall life cycle of the value chain. So basically, what are the real ecological impacts of the battery from the extractions of resources down to the recycling of the battery. And we create one very interesting application on the Tesla 3 models. We also create application on the carbon neutrality. So if I'm the big boss of one huge company that reject some carbon on the atmosphere, I can imagine to invest some money to reduce the carbon impact of my industry. So the basic question is: does I need to create a forest of trees, or do I need to invest on some technology to capture the CO2 from the air? Basically, okay. So we create one Giggly to tackle such problems. So I use this webinar to call you for a project. So what's next in Giggly? So we are looking for the next subject of interest to tackle. So if you have any concerns or difficult things that can be tackled by Giggly, we are looking for some new challenges. So if you have it, please send us an email to contact@giggly.net in order to challenge ourselves. So thank you very much. So if I conclude this webinar, what we have to remember from this first one. So first of all, what are the benefits of augmented human intelligence? So we are all facing to the same collective intelligence. We need much more collective intelligence than before, due to the fact that around the project up to now, we have much more specialized disciplines. So we are involving much more disciplines, and it's not anymore possible for one guy to be able to analyze the overall collective intelligence. The field of opportunities and new technology has never been so wide. So basically, we have almost every day some new technology that can be a breakthrough for large companies. When we understand these two first steps, we understand that we need exploration tools in order to use as best as we can this collective intelligence and to explore the field of opportunities. And when you understand that we have these capabilities to explore a large design space, a large trade space, we understand that we need decision tools to support our decisions and to take the right ones. And this is exactly the value chains of Gigli. Okay. So second things to remember is that we've seen that using augmented human intelligence software, we are able to shift the paradigm by talking about, instead of talking about techniques and designs, we can directly talk about what we expect at the end, what are the system perspective we want at the end, and to get the right architecture. So we can have a shift that is going to create value for the engineers and to relax constraints on the design teams. Okay, so up to now, Gigli, that was known as the Google of engineering, dedicated to engineering, it's not anymore only an engineering software. We are a cross-discipline platforms managing engineering, human resources, financial engineering, innovations, and one other aspect that I didn't present today, that is the corporate social responsibility, which is one part of the performance of our company. Okay. So I encourage you to register for the rest of the webinar. So on the 6th of May, we will have a dedicated webinar about engineering, in which we are going to details in much more deeply how Gigli engineering patterns and Gigli engineering intelligence are working. On May the 20th, we will have a dedicated workshop webinar about the finance analysis and the road mapping analysis using Gigli. On May the 27th, we will have a dedicated webinar about human resources with augmented human intelligence. And on June the 3rd, we will have a dedicated webinar with hybrid about innovations and the perimeter of ambitions. And on June 10th, we will have conclusions, a summary basically of strengths and weaknesses about augmented human intelligence. We still have improvement to do on this field. So thank you very much. I think we might have 2, 3, maybe 5 minutes to answer to some questions if we have. So I hope it was enough clear for you. Sorry for the delay. So thank you very much for your attention. And Lucille, I'll let you the floor.